Hi all, welcome to our channel Instrumentation Academy. In this video, we will learn how a differential pressure flow meter works. Differential pressure flow measurement is a well-known and common technology for measuring flow. Differential pressure flow measurement consists of two main components: the primary element that is installed in the pipe and the secondary element that reads the differential pressure signal. Differential pressure flow meters introduce a constriction in the pipe that creates a pressure drop across the flow meter. When the flow increases, more pressure drop is created. Impulse piping routes the upstream and downstream pressures of the flow meter to the transmitter that measures the differential pressure to determine the fluid flow. The basic working principle of differential pressure flow meters is based upon the Bernoullis equation, which states the fact that the pressure drop across the meter is directly proportional to the square of the flow rate. The flow rate is calculated by measuring the pressure differential and extracting its square root. There are different types of primary element. The most common types are orifice plate, venturi tube, and pitot tube. The secondary element reads the differential pressure generated by the primary element. The most common secondary element used in industrial flow metering is the differential pressure transmitter. Differential pressure transmitters are designed to convert the mechanical pressure signal into an analog or digital signal and convey it to the control system or panel. This figure shows a simple differential pressure transmitter. If it is desired to have an output proportional to flow, the square root of the differential pressure measurement can be calculated by the transmitter. Components of a transmitter. Process connection. The process connection is used to connect the transmitter to the process. Common process connections include manifolds, impulse piping, and primary elements. Sensor module. The sensor module houses the sensor. The sensor reacts to changes in the process by creating a signal which is read by the electronics. Depending on the type of pressure measurement, the sensor will be mainly capacitive or piezoresistive. Housing. The housing is what protects the electronics of a pressure transmitter. Housings can come in various materials depending on the application. The transmitter housing can be intrinsically safe and explosion-proof to protect the electronics from hazardous environments. It also provides terminations for communication wiring in the field. Electronics. The transmitter electronics take the output of the sensor and turn it into a standard electronic signal. The most common transmitter output signal is 4 to 20 milliamperes. This signal is used by the transmitter to communicate with the control system. The majority of industrial differential pressure transmitters are fitted with diaphragm as the pressure sensing element. This diaphragm is a mechanical device. It is placed in between the two pressure inlet ports. By removing 4 balls from the transmitter, we are able to remove 2 flanges from the pressure capsule, exposing the isolating diaphragms. Every differential pressure transmitter has 2 pressure ports to sense different process fluid pressures. One of these ports is labeled high and the other is labeled low. This labeling does not necessarily mean that the high port must always be at a greater pressure than the low port. What these labels represent is the effect that a pressure at that point will have on the output signal. Once a transmitter is installed in the line, the pressure measurement starts at the transmitter's isolating diaphragm, which is a thin flexible disc that is usually made of metallic or ceramic material. This is the part of the transmitter that comes into direct contact with the process medium. The concentric corrugations in the metal of the diaphragm allow it to easily flex with applied pressure. As process pressure increases, the isolating diaphragm begins to flex. The change in pressure is then transferred from the isolating diaphragm to the transmitter sensor. It is common to have oil behind the isolating diaphragm, which is pushed to sensor by the flexing isolating diaphragm. The sensor inherently measures differences in pressure applied between its two sides and convert it into an electrical signal. By this we come to the end of this video. If you like this video, please support us by subscribing our channel. Thank you. Have a nice day.